Hi everybody, welcome back to my videos. I'm going to be going through today mock set 3 paper 2 for you. Okay, let's get started. As always, if you like the videos, make sure to like them and subscribe and turn on that notification bell, because that will make sure you don't miss any of the videos, any of the past papers, any of the mock set papers that I'm going through. Okay, question 1. Oliver records a distance from London to each of 8 cities in the USA. He also records the time taken to fly from London to each of these cities. The scatter graph shows information. So we've got time taken to fly and then we've got the distance. Okay. Chicago is a city in the USA. Chicago is 4,000 miles from London. By drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. Okay, so we need a ruler and a pencil so that we can draw, nearly dropped my ruler there, a line of best fit. Always use a ruler, always use a pencil and a ruler, pencil in case anything goes wrong. Now, with a line of best fit, generally you want about the same number of points either side of your line, but that's, the best case scenario. So here I've got, they're about on the line, that's about on the line. One, maybe want a bit up here, like this. So 2 below, 2 above, that one's on, that's about it. Okay, and that's your best kind of estimate. It's a line of best fit, so everybody's is going to be very slightly different. Okay, so that's not quite perfect, so I'm going to use my rubber and try and do it again, because that wasn't quite where I wanted it. That's why it's important, like I say, you do it in pencil. So I want to go about there. Now we should only go really about the length of the points we've got, because we don't know beyond those points what would happen. We don't really have any data for it, so we can't just presume that it would carry on going in this straight line, and it would be in direct proportion. So now we've got a line of best fit. If I go back, Chicago is 4,000 miles from London. Okay, so 4,000 miles from London distance, we're going to go across from 4,000 until we hit our line of best fit, and then we're going to go down. Again, use your pencil. Now you want to draw these lines because this is your working out essentially. So if we lose any marks, or if we're not quite in the range they want us to be, we've got our working out down, so they may still be able to give us some marks. And I've got this 450 to 500, so each 2 little squares here is going to be 10, 460, 470, 480, just above 490. So 495 would be in the middle. I'm going to go 492. Okay, 492 minutes. Now my line was between the little squares, so it's an estimate, and like I say, there will be a range of answers, a range that your answer can be in for that. Okay, why is your answer to part 1 only an estimate? It is estimate because I have used a line of best fit, and essentially this isn't, it's not perfect science. It's not going to be exactly the same for everybody, so I've used a line of best fit, and this can vary from person to person. Something along those lines to do with the line of best fit. Okay, and the fact that it's, like I say, not perfect. It's not perfect science. Calculate the gradient of your line of best fit. Okay. So if we go back here, line of best fits, the gradient. To do the gradient, we want 2 points really. So let's have a look. I want to find some points where it fits nicely onto my grid lines. So I'm just looking for, and the further away you can get, the better. Let's go with the top point here, and our bottom point here. So that's 410, and it goes up to 3,100, 3,200. Yeah, each 2 little squares is 100 here. So 3,200. So we've got 410, 3,200 as 2 of our points. Sorry, 1 of our points. 410, 3,200. Now I need another point that I can use, and I'm looking for points on this line, and the furthest away would be better. So let's go with this one. Now that would be 645 and 5,500, because that is just 1 little square down from 650. And it's about 5,500. So 645, 5,500. Okay, now through the gradient, it's the change in y, often written with a triangle. Change in y over change in x, or the difference in y over the difference in x. So I'm going to take away my y values, 5,500, take away 3,200, and we're going to divide that by. You've got to take them away in the same order now. The x value is 645, take away 410. And I'm going to grab my calculator, I'm going to plug that in, and that will give me my answer. Okay, 9.79 to 2 decimal places. Okay. Now and then it says give an interpretation of the gradient of your line of best fit. So an interpretation is basically saying, what does this mean? So if I go back, I've got here, this is it's going to be the rate of change. Gradient is always the rate of change of something. Okay, it's the rate of change of the distance over time. So as time increases, how much is the distance increasing? Okay. So this is basically per minute, how much is the distance increasing? Well, it's increasing by 9.79, okay? Now, another way of writing or explaining, or another word for the rate of change of distance as time increases is speed, okay? Speed is miles per hour. That's telling you how many miles the distance is going to change by every hour, or go up by, if you like. So the gradient of this graph is going to be the speed. Okay, so this is the speed, and we'll put it into context. It's the speed to fly from London. Well, no, it's the speed. It's the speed that the aeroplane would be flying at, if you like. The gradient represents the speed in, and then this would be, because the time taken is in minutes, we've divided by minutes, miles, in miles per minute, in miles per minute of the flights. Okay. Question 2. Okay, now it says rotate shape S clockwise, center 5, 4. Now if you're at home, what you'll need is some baking paper or greaseproof paper. I've got some next to me, so I'm just going to rip a piece of that off, and then you can use that essentially as some tracing paper. Now again, you'll need your pencil. Okay, so rotate shape S 90 degrees clockwise, so clockwise is the same way that the clock goes. Center 5, 4. First thing I need to do is I want to just trace the shape over the top. And it only needs to be tracing it because I can use my ruler. Well, so it's going to give me a rough idea of where it would be, and then afterwards I can use my ruler to draw it properly once I've rotated it. Okay, so there's my shape traced on. So center 5, 4, that's where I'm going to put my pencil. So 5 here on the x-axis, and then up to 4, which is here. Now, ideally, what I should have done for this is I should have made it so that my tracing paper was rectangular, because then that would be easier to tell when I'd done a quarter of a turn or 90 degrees. But it's okay, because actually this side here, the top bit, is in line with this. So actually when I've done a 90-degree turn clockwise, it should be going in the same direction as this line on the side. So we'll do that. So there we go. And what we should find is that these points should line up with where your grid lines cross. Okay, so there. Okay, now I'm going to move my pencil, and what I want to do now is I'm just going to hold that in place, and I'm going to peel it back and just put the corners of this triangle on. So first one goes here. I'm going to use dots for this, just so that when I draw it afterwards, they won't be able to tell that I've drawn these dots, because I'll go over them. And the other one is going to be, this is a bit harder because I'm left-handed. There. And then the last one is 1 right from that left corner and 2 down. So 1 right, 2 down here. Now I'm going to get my ruler and I'm going to join those points up. Okay, label your image T, so call that T. Describe fully the single transformation that will map shape T onto shape S. Okay, well, I've got to do one transformation, and well, it needs to go back from T now to S, so it's just going to be basically the reverse. So rotation, anti-clockwise this time, at 90 degrees, center 5, 4 again. So everything is in exactly the same place, apart from this time I'm just going to rotate it anti-clockwise. Okay, so instead of going the way the clock goes, it's going to go the other way, and then it'll end up back here. It's got to. Okay. Question 3. Here are 2 rectangles, all measurements are in centimetres. The area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. So first thing we need to do is work out this x here, and it says the area of rectangle A is equal to the area of rectangle B. So 4x times by 2.5 has got to be equal to 7 times by 2x minus 3. 4 times 2.5, well, I can do this on my calculator, but half of 4 is 2. 2 times 4 is 8, add the 2 is 10. So that's 10x. I will just check it on my calculator. And then the next one, 7 times by 2 is 14. X, 7 times by negative 3 is going to be negative 21. Okay, then to solve that, I'm going to take away 10x from both sides. And we're going to get 0 is equal to 4x minus 21. and then I'm going to add 21 to both sides, and then I get 21 is equal to 4x divide by 4 on both sides, and I get 5.25 equals x. Okay, I've underlined that because that's part of my answer, and that's what, you know, they'll be looking for that when they're marking it. I'm just going to check that by plugging that in. So 4 times by 5.25 is 21, so this is 21 here. 2 times by 5.25 minus 3, that gives me 7.5. So I'll just check on my calculator. 21 times 2.5 is 52.5, and I'll just check 7 times 7.5 gives me the same answer. It does. Yeah, so those areas are the same, and I know that's right now. Okay, now work out the perimeter of rectangle B. So then we've got 7.5, add 7, add 7.5, add 7. So it's 29 centimeters. Question 4. The diagram shows a fair four-sided spinner. Hazmi is going to spin the spinner twice, complete the probability tree diagram. Lands on A, well that's 3 out of 4, lands on B is 1/4. The second spin shouldn't be affected by the first spin, so that's going to be exactly the same. So 3/4 A, 1/4 B, 3/4 A, 1/4 B. Work out the probability that the spinner will land on A on the first spin and will land on B on the second spin. So if we're going along our branches here, you've got to multiply. So 3/4 times 1/4 is going to give me 3/12. Wait a second. 3/4 times 1/4 is going to be 4 times 4 is 16. So that's not 1/4, that's 3/16, which is just 3/16. You can't simplify that, not 3/12. Okay, question 5. A is 8, B is 10, calculate the value of S. Now all we need to do here is plug this into our calculator. Given we've got a Casio calculator, this should look exactly the same. So it does say S equals, so all we've got to do is substitute this in. So shift and then standard form button to get pi squared, just put it in the light so we can see, brackets. Now I've got B squared, so that means 10 squared because B is 10, subtract 8 squared because A is 8, press equals, and I'll just write down what I've done. Pi squared 10 squared minus 8 squared is equal to 355.3057584. Now I need that to 3 significant figures, so that's my first significant figure here, second, third, so I'm going to look at my next number, that's 3, so that means that 5 is going to stay the same. My third significant figure will stay the same because my fourth one is below 5, so it's going to be 355, and then you can put 0.000, but because it's 3 significant figures, we should have 3 significant figures, and if they're after the decimal point, it should be, you know, we don't need to write the 0.000. There's no need to do that. So 355, and we don't need to write 3SF in brackets because it says it in the question. Okay, only blue vans and white vans are made in a factory. The ratio of the number of blue vans to the number of white vans is 4:3. Write down the fraction of vans that are blue. Okay, the ratio of the number of blue vans to the number of white vans is 4:3. Now, what I always do with ratios is use bar modelling, or boxes as I call them. I only call them boxes so I can add another one on if I need to. And so, blue to white, so blue vans 4 and white vans 3. Write down the fraction of vans that are blue. So in total there's 7, and blue is 4 out of the 7. For blue vans, the number of small vans to the number of large vans is 3 to 5. Okay. Work out the fraction of the number of vans made in each factory that are blue and large. Now, what I want to do here, I've just thought, if I add these parts up, I've got 8 parts in total. Now that, I need to split basically the blue vans into a multiple of 8, so that I can then split them up into this ratio. And fortunately for me, the parts of the blue vans already is 4, so I can just double this ratio, or use an equivalent ratio, double both of them. So I'm going to get blue is 1, 2, 3, 4, 5, 6, 7, 8. White is going to be 6 now. So this is an equivalent ratio. 5, 6, 1, 2, 3, 4, 5, 6, 6, 7, 8. I've done my boxes for my white vans slightly bigger, but that's okay. Now 3 of these 8 are going to be small. So I'll put an S in there for small in 3 of them, and then 5 large. 4, 5. Work out the fraction of the number of vans made in the factory that are blue and large. So we've got 5, 1, 2, 3, 4, 5 out of, well, this is 8 parts and this is 6. So 8 add 6 gives me 14. I'll just double check by counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So 5 out of 14. Work out the fraction of the number of vans made in the factory, so in total is 14, that are blue and large. So blue and large, which is, 5. Okay. Question 7. Find the reciprocal of 5. So reciprocal is going to be, well, what could I times by 5 to get 1? Well, it's got to be 1/5. Okay, so 1/5 is my answer. Use my calculator to work out this. This is just a case of knowing where all the buttons are on my calculator and what to type in. And again, if you've got a Casio calculator, this should look exactly the same. So first thing I need to do, because it's over everything, is the cube root. Now on my calculator, I'll just make it so we can see all the buttons. Above the square root is this cube root button. So I'm going to press Shift and the square root button to get that. And then I'm going to next do 5 tan 60. So 5, and I could just write tan 60. I've got to close my bracket here because the tan function has an open bracket at the start, so I have to close it, and then +1. So it looks exactly the same apart from mine's got brackets in. Press equals and it will come up with the answer. Now what you do have to make sure is, if you notice at the top of my calculator here, it's got D, that stands for degrees. If it has R, that stands for radians, which is not to do with GCSE maths at all, that's to do with A-level maths, but obviously the calculator can do it. In 99% of cases your calculator won't be in radians because you've never had to use it before, but sometimes that has happened from just the calculator being in bags and doing it, not itself, but hitting against things in bags and whatnot, and just changing without you knowing. And you wouldn't know because you don't have to use it and you don't have to know about it. But yeah, make sure it's got the D at the top there for degrees. That only matters when you're using a trig function, so sine, cos and tan. Okay, so in this instance, because I'm using tan, I've got to make sure it says that D at the top, degrees. Write down all the figures on my calculator display. So I've got to write down all of these. 2.129754359. There we go. Next one, question 8. Make T the subject of this. Now, first thing I want to do is I'm just going to do a balancing line down here. I don't like the fact that this square root symbol is over everything on the right hand side, basically covering T and everything else there. So I want to square both sides. First of all, and that is going to give me P squared is equal to A plus T over 2. Now I've got to think about the order of operations here. So in terms of my t, if I was to substitute a number in, like 4, I would do 4 divided by 2 and then add on the a. So as the a is the last thing that's happening, adding the a is the last thing that's happening, that's the thing that I've got to undo next. Okay, you've got to break it apart bit by bit. So I need to take away a from both sides. So that's going. I have to take away a because this is a positive a, and so to cancel out positive a, take away a. That will give me 0. Cancel out. P squared minus a is equal to a. Take away a is 0, and then I'm just equal to t over 2. Now I've got t divided by 2 here. I need to do the inverse operation. So instead of dividing by 2, I'm going to times by 2 on both sides. Now, what people will do is they'll make a mistake at this point, if they haven't already earlier on, in that they will just times p squared by 2 or just times a by 2. Now, we're timesing everything on this, on both sides by 2. So I need to times p squared by 2 and this a by 2. Alternatively, what you could do is put just this left-hand side in brackets. So I could just write it like this, 2p squared minus a. So 2 lots of that is equal to t divided by 2 times by 2 is t. Okay, and that's my answer. So I'll just write that on my answer line, 2 lots of p squared minus a. So squaring it, because that was the, again, the last thing you would do. So substitute a number in, 4 over 2, add a, and then you square root it. So you basically work backwards. Whatever the last thing you would do, that's the first thing you've got to undo. So square it, take away the a, and then times by 2 on both sides. Okay, question 9. In the diagram, A, B, C, D, E, F, G are parallel lines. Angle ABE is equal to X, EB, so EB is equal to EF, that's shown on there by these lines through the sides, or through the lines, if you like, through EB and through EF. That means that these sides are equal, which means that EBF is an isosceles triangle, and this angle here is equal to this angle. Okay, show that W is equal to 90 plus a half X. Give a reason for each stage of your working. Okay, now I know this has got to be X here, X degrees, because of alternate angles are equal, and that's in kind of a Z shape, if you like. So angle BEF is X degrees as alternate angles are equal, so angle BEF is equal to angle ABE. And then next thing to know is, well, we know these two angles have to be equal. We know there's 180 degrees in a triangle. So if we do 180 degrees, take away X and half it, we will find out this angle. Okay, so this is going to be here. What I'll do is I'll write down my working out and work it through as I'm writing down my reason. So angles in a triangle add up to 180 degrees. That's the next fact we're going to use. And angles at the base of an isosceles triangle are equal therefore angle EFB is 180 minus x, because if I take x from 180 I get both of these angles, but I want one of them, I want this one, so I'm going to half it. 180 minus x divided by 2, which is 90 minus a half x, and then I'll write that on. 90 minus a half x. 180 divided by 2, and then I've got minus 1 divided by 2, which is minus a half. Okay, and the last reason is, this is on a straight line, so angles on a straight line add up to 180 degrees. Therefore, angle W is equal to 180 minus 90 minus a half x. And I'll put this in brackets because I'm taking away the whole thing. And again, what some people may do here is just take away the 90 and they're left with 90 minus a half x, but that's not what is going to happen. I'm taking away both things. So I've got 180 minus 90, which is 90, and then if I subtract negative a half x, or if I take away a half x, that's the same as adding positive a half x. So that's the same as 90 add a half x, which is exactly what we wanted up here. Okay, so there we go, we're done. Question 10. In 2016, the population of the UK was 6.5 times 10 to the power of 7. Laura wants to calculate an estimate for the population of the UK in 2020. She assumes that the population increases by 0.6% each year. Using Laura's assumption, calculate an estimate for the population of the UK in 2020. So if it's increasing by 0.6%, I can work out the multiplier by doing 100 add 0.6. So 100% add 0.6 gives me 100.6%. Now that as a decimal is 1.006. Okay, so if I multiplied my initial value by 1.006 for 4 years, that would give us our answer. So, or 6.5 times 10 to the 7 times by 1.006 to the power of 4, because it's happening 4 times and it's going to be compounding this increase. Okay, so now I'm just going to type that into my calculator. I'm going to put the first bit in brackets just so there isn't any confusion for the calculator in terms of powers and whatnot. So times by 1.006 to the power of 4. And that's going to give us an answer that isn't in standard form, but that's okay because it wasn't going to be, because it's got, you know, all of these. There's not a lot of zeros, put it that way. Whereas, you know, 6.5 times 10 to the 7, there's going to be 6 zeros. So that's a number that makes sense to put in standard form. But, you know, this doesn't have loads of digits at the end that are zeros, so it doesn't make sense. It wouldn't make sense. So that gives us our answer 600, well, not 600, sorry, 66,574,096.24. So I mean, that's our estimate, but you can't have 0.24 of a person. So in my head now, I'm just considering, do I leave this as it is because it's an estimate? Do I, you know, round it or truncate it, because you can't have point anything of a person. Now I'm just going to, I was going to read the rest of the question just to see if, or just to make sure I've been following this the way it wanted me to follow it. I'll read it again just to make sure. In 2016, the population of the UK was 6.5 times 10 to the 7. Laura wants to calculate an estimate for the population of the UK in 2020, 4 years later. She assumes that the population increases by 0.6% each year. So 4 years have gone by, so power of 4, and multiply 1.006. Using Laura's assumption, calculate an estimate for the population. Okay. What I'm going to do is I'm actually going to write, approximately underneath, and I'm going to leave my answer as to, well, I'm going to truncate it essentially. I'm going to get rid of the 0.24 at the end, because you can't have 0.24 of a person. I'm going to leave it as that. So I've got both basically answers there. I've shown my working. Both are right. This is approximately. If you're going, by, if you wanted it as an actual representation of people rather than just an estimate. So I've got both there, and that's kind of covered all bases. Okay. Kieran also assumes that the population of the UK increases by 0.6% each year. He says that it will take over 80 years for the population to increase by 50%, because 50 divided by 0.6 is 83.3 recurring. Kieran's method is wrong. Now, really, what Kieran needed to do is essentially, he's got, if it's going to increase by 50%, then we want basically the number of years that we would have to have 1.006 to the power of, so that it was bigger than 1.5 in total. That's what we're looking for. So we could do a bit of trial and error. It doesn't actually want us to do that. It just wants us to explain what is wrong with his method. So his method is also using 0.6, which would be 60%, and that would just find you 60%. As for what is actually wrong with his method, I mean, it's a bit of kind of, where do you start? Why has he done that? Where's that come from? 50 divided by 0.6. He's finding out how many 0.6s go into 50. Essentially, what he's done is he's treating it as if it's kind of simple interest and it's not compounding. Because if we just kept adding 0.6% on and they were the same each time, then this would be okay and that would work. Now, if we do this, so 1.006 to the power of 80, let's say, I mean, that's over 1.5. Okay, so it's not going to take 80 years. And really, in practice, what I would do is a bit of trial and error with this. So it's a bit less than 70. Let's go 68. Okay, it's a bit less than 68. Let's go 67. Okay, so 67 is just below. So actually, it's going to take 68 years to increase by 50% in total. Okay, so Kieran's treated as if it's simple interest, or well, not simple interest because we're not talking about money. How am I going to phrase this? Explain what is wrong with this method. Kieran has not considered that the percentage increase will compound each year, and so the increase will not be the same. Okay. Now, the next bit, assuming that the population of the UK increases by 0.6% each year, show that the population of the UK each year forms a geometric progression. So geometric progression essentially means that I can multiply by some number to get the next number. Now, that's fairly obvious given what we've written up here. So, in terms of a show that question, maybe they weren't assuming we would have done it this way, part A. And so maybe they were hoping that by part C we were just going to realise this and work out what it's being multiplied by. So let's just do year 1, year 2, year 3, because to show that question we've got, actually I'm going to do 2016, 2017 and 2018. So we've got 6.5, I'll just change that into an ordinary number. 6.5 times 10 to the 7 is 6, 5 with 6 zeros, 1, 2, 3, 6, so 65 million. Year 2017 is going to be 65 million times 1.006. Okay, so 6, 5, 3, 9, and then 4 zeros. And then times by 1.006. 6, 5, 7, 8, 2, 3, 4, 0. Okay, now with the geometric progression, essentially we've got basically some starting number and we're timesing by some number each time. So times by something, times by something. Now we know what these are. This is going to be 1.006, 1.006, and so essentially what we get is 6.5 times by 10 to the power of 7, because that's that first number, times by 1.006. And if you wanted to write this as an nth term, the nth term for a geometric progression, you just put the power as n minus 1, because for the first one it's 0, so sorry, 1, excuse me, the year is 1. Sorry, no, it's not going to be the minus 1, is it? Excuse me. First year, so that's, well actually no, I was right the first time, n minus 1, because this is your first term, this is your second term, this is your third term. Okay, so nth term would be this. So this is my starting number. Now on the first one, 1 take away 1 is 0, anything to the power of 0 is 1, so this basically disappears and we just get that number. Next one, 2 take away 1 is 1, so this times by this, and so on. And yeah, so I suppose that's it. I mean, probably all we had to do was show this bit here, but we probably wouldn't need the nth term. But that's just an added extra bit to show this is the nth term for a geometric progression. The key word there is just geometric. You've got to show that you're multiplying by some number, the same number each time. Okay, next question, question 11. Anna and Bill share some money in the ratio of 2 to 5. Anna gets A pounds, Bill gets B pounds. Carl and Donna share twice as much money as Anna and Bill share. They share the money in the ratio of 3 to 1. Carl gets C pounds, Donna gets D pounds. Find A to B to C to D. Okay, now what I'm going to do is, if I have A, B here, and then I want total, and then I'm going to have C, D here, and total. So A to B is 2 to 5, and 3 to 1 for C to D. Now I'm looking for the total for C to D to be double the total A to B. So at the minute I've got 7 and 4, so let's do another C to D to get above A to B. So 3 times 2 is 6, 1 times 2 is 2, so that total is 8. Right, I'll keep going with this. I'll just do a few of these in the list. So 3, 6, 9, 12, 1, 2, 3, 4, essentially times tables are multiples of the ratios, or equivalent ratios. 9 add 3 is 12, 12 add 4 is 16. Okay, and then I'll do some of these. So 2, 4, 6, 8, 5, 10, 15, 20, and then our totals for each of these. So 4 add 10 is 14, 6 add 15 is 21, 8 add 20 is 28. So I'm going to need to go, there's none that I can see at the minute, which I'll double these. I'm going to need to go further. So 12, 15, 18, 21. 4, 5, 6, 7. 15 add 5 is 20. There's no 10s over here. 18 add 6 is 24. There isn't a 12. 21 add 7 is 28, and there is a 14. Okay. So from there, I've now got the total of C to D is double the total of A to B. So I've got as my ratio 4 to 10 to 21 to 7. Now, can I simplify that in any way? Probably not, as long as that's the smallest, or as long as that's the first number that is double for C to D of A to B, which I think it is, because there's no 14 in here, so it must be. So no, I can't simplify that. 2 is the only factor of 4, apart from 4 and 1, and that doesn't go into any of them. Okay, so 4 to 10 to 21 to 7. Okay, question 12. The length of QR is 60% of the length of PR. And I'm going to use as a multiplier again, so 0.6. The length of QR is 60% of the length of PR. So this is 0.6 PR. Okay, this is PR. That's 0.6 PR. Find the value of sine QPR. So I want the sine of this. Now, if I do toa, sine is opposite over hypotenuse. Now if I'm doing this angle here, this is the opposite, so QR is the opposite, and then hypotenuse is this one. Okay, so right, it would have been a lot easier if it was opposite over adjacent, but we've got a right angled triangle, and so what we can do is square them, add them together, square root, and that will give me H. So let's try that. So we've got PQ is equal to PR squared plus 0.6 PR squared, and then we're going to square root it. So that is equal to PR squared plus, now 0.6 is 3/5, 0.6 squared is 9 over 25 PR squared. So I'm going to get 1, add 9 over 25, so add 1 is 34 over 25, so I've got square root of 34 over 25 PR squared, which is, so square root answer, root 34 over 5 PR, because I have to square root both things there. Okay. So the hypotenuse is root 34 over 5 PR. Okay, 0.6, I could write that as 3 over 5 PR, just to keep everything in fractions, although it's not going to matter, we've got a calculator. Sine of QPR is equal to opposite, so 3/5 PR over the hypotenuse, which is root 34 over 5 PR. Type that into my calculator and let's see what I get. So fraction and then 3/5. I can't type the PR in, but they will cancel top and bottom, so that's not going to matter. Divided by fraction on the bottom, root 34 over 5. Press equals and I get 3 root 34 over 34. Okay, so just give my answer 3 significant figures, so that is going to be 0.514. The PRs will cancel top and bottom. I've got PR divided by PR, which is 1, so I get 0.514. Okay, and there's my answer. Okay, question 13. Okay, so it says here are 5 graphs. Each graph shows either direct proportion or inverse proportion. Okay. Now the table shows 5 equations. Match the letter of each graph to its equation. Now, direct proportion is essentially as one thing increases, the other thing increases. And inverse proportion is essentially as one thing increases, the other decreases. And so actually really the only one that would be inverse proportion is if I start from 0, as time goes up, y is coming down, it's decreasing. So A would be the only one that is inversely proportional, and the equation for inverse proportion is y is equal to k over x, so that's got to be A. Now from there really it doesn't come down so much to do you know inverse and direct proportion, because all the rest are direct proportion, they're just at different rates. And they're proportional to different things, you know, x squared, square root of x. So what we really need to know now is the equations for graphs. Now this is going to be, it's a straight line, so that is y is equal to something x, y equals mx plus c. Okay, so y equals something times by x, and the plus c has got to be 0 because it goes through at 0. So that's got to be y is equal to kx, so b goes there. Now c is actually the square root graph. Now the square root graph, if you have the positive and negative, it goes the other way. It's like kind of a rotated quadratic. Okay, it's turned from being a U shape and it's turned this way, so it's around, instead of my y-axis, my x-axis. But you only get half of it because functions can only be 1 to 1. If I put in an x value of 3, I should only be able to get out 1 y value. Whereas if I have the other side, the positive and negative, I could get out, you know, if I plug in 3, if I plug in, let's say 9, I could get positive 3 and negative 3 as the square root, which, you know, we know that's true, but it just won't work for a function. We need to have one output. So that is y is equal to k times the square root of x, so that's c. And then d is a quadratic graph because it's a U shape, so that's going to be x squared, y is equal to kx squared, that's d. And then e is a cubic, because well, essentially it should, well, usually, not it should, usually a cubic would have 3 roots, but it's got 1 repeated root at the center, in the same way that a quadratic usually has 2, but it's got 1 repeated root again at the origin, so it just touches and comes back up. The cubic touches and then carries on going up, so E has got to be a cubic graph. Okay, question 14. A cafe owner sells 10 different types of sandwich. Raheem buys a different type of sandwich on Monday, on Tuesday, and on Wednesday. In how many ways can he do this? Well, on Monday he's got 10 options of sandwich to buy. Now, whichever one he buys of those, he can't buy the same one on Tuesday because he buys a different type. So then he's got 9 options on Tuesday, and on Wednesday he's got 1 less again. He's got 8 options. So that will give us the number of ways he can do it. So 10 times 9 times by 8 gives us 720 different ways he can buy a sandwich in that week. Okay, question 15. Okay, so we've got to draw a histogram. Shows information on the times of a group of students took to do a park run. Now what I need to do here is add on a frequency density column. Now frequency density, I'm going to see, basically if I was to split these 20 up into, well, the 25 minutes, on average how much would 1 minute have, if that makes sense. So I'm going to split 20 up into 25. So 20 divided by 25 is 0.8 on my frequency density. Okay, so 35 now split between 20. 35 divided by 20 is 1.75. 45 split into 15. 45 divided by 15 is 3. And then 87 divided by, this is 15, gives me 5.8. 10 divided by 10, that's the width there, 75 to 85 is 10 wide, so 10 divided by 10 is 1, and then 8 divided by 10 is 0.8. Okay, so the tallest I need to go up to is 5.8, and I've already got the time down here, so if we do one big square is 1, 2, 3, 4, 5, and then 6 up here. So 1, 2, 3, 5, 6. Could go up to 7, but I'm not going to need to. Okay, now pencil and a ruler because we're doing a graph, just in case anything goes wrong. So 0 to 25. 25 is going to be exactly in between 20 and 30. And that goes up to a height of 0.8. So I'm going to do that again because that line is supposed to be in the middle, but it's a bit too close to 26. That's a bit better. So there's 25, and that's got to go along at 0.8. Going to make that line just a bit thicker here, easier to see. Okay, and then from there, 25 to 45 is a height of 1.75. So let's go up here to 1.75, which 1.5 is exactly halfway in between. So this is a bit tricky to draw because going in between all the squares. 1.75, and I've got to go along to 45, so join these up. Okay, so 25 to 45 at a height of 1.75. And then I've got to go up to 3, and I'm going from 45 to 60. That's a bit easier. So up to 3, 45 to 60. Scale on this, the bottom of this graph hasn't made this very easy at all. Okay, and then 60 to 75 has got to go up to 5.8. So 5.8 is here. And that's got to go along until I get to 75. So 75 is here. Put my pencil down first, and I can bring my ruler over to it, and I can kind of see where the ruler needs to be then, once it's right next to the pencil. And join that up. And then the next one is at a height of 1, 75 to 85 at a height of 1. It would have made it a lot easier had they put the 5s in between, because all of these go to 5s, but then you have to go in between all the little squares, making my life really difficult. That's at a height of 1. And then we've got 85 to 95, which is at a height of 0.8. So again, up from 95. Okay, then we might want to just do some shading in here just to show where our histogram is and where it goes up to. This isn't compulsory, but it just makes it easier to see where our lines are, how tall our bars are. Okay, there we go. Not the easiest thing to do because of how they've put all of these at the bottom, but there we go. Just got to make sure you're as accurate as you can be with that. So if it should be in between the squares, make sure it does go in between the squares, and make sure you use a pencil so you can correct it if you need to. Okay, there's the best picture. Okay, next question, I think, unless there's another question on this. Nope, question 16. (16a). Show this equation has a solution between x equals 2 and x equals 3. Okay, pick my pen back up again. What we want to do is substitute in 2 and 3 into this, and so show that we get a positive answer and a negative answer, which means because it's a polynomial, it's continuous. Because there's a change of sign, therefore it must have gone through the axes. There must be a solution in between. So let's just say let f of x, a function of x, be equal to x cubed minus 3x squared plus 3. Then we're going to say f of 2, so we're going to plug 2 into our equation, and we're going to get 2 cubed minus 3 times by 2 squared plus 3, and we're going to see what that equals. Now this should be either positive or negative, and the other one will be the other. So if this one's positive, then 3 should be negative. So we get -1. So this was negative, which means when I do f of 3, we're going to get a positive answer. And on my calculator, I'm just going to change the 2's in here for 3's. And I get a positive answer. And then you've got to write the statement as there is a change of sign for x equals 2 and x equals 3 in our answers, i.e. one's positive, one's negative, there must be a solution to the equation between x equals 2 and x equals 3. There we go. Show that the equation can be rearranged to give this. Okay, now what I'm looking at is, well, this is cube root, and that's over everything. So that must have been the last thing that they did in the rearrangement. So I want to get x cubed on this side is equal to something on the other side, and then I can just cube root it, and then that should be nice and easy. So I'm going to start off with this, x cubed minus 3x squared plus 3 equals 0. Now I want to get everything that isn't x cubed onto the other side, and then I can cube root it, because that's the last step obviously here. So plus 3x squared to both sides. X cubed minus 3x squared plus 3x squared will cancel. Plus 3 is equal to 3x squared. And then we need to do minus 3 from both sides. And we get x cubed is equal to 3x squared minus 3. And then the last step is to cube root. X is equal to cube root of 3x squared minus 3. Okay, there we go. Starting with x0 equals 2, use the iteration formula, basically the equation we just worked out, to find the value of x2. Give your answer correct to 3 decimal places. So x0 equals 2. Now the way to do this is to just type it on your calculator 2, and now that's going to be my answer button. So x1 is going to be the cube root of 3 times by 2 squared minus 3. Now what I'm going to do is do cube root, so shift cube root, 3 times by answer squared, because answer was 2, and then minus 3. So this will be x2, so that is 2 point, oh sorry, this is x1, excuse me, this is x1, I've just typed that in, 2.080083823, and then the next bit is going to be basically cube root of 3 times by, I'm just going to put in here, x1 squared minus 3. Now instead of having to type that number all in again, and instead of having to type this in again, this 2.0800 blah blah blah, the rest of it, I'm just going to press equals again, and it will take this and it will replace answer with my answer. So it just plugs back in x1. So press equals, and I get this. This is x2 now. And that saves you having to type all the numbers back in again. It's an iteration formula, so essentially what it does is it takes your answer, plugs it back in, and does the same thing. So I could keep pressing this, and I'll get closer and closer to the solution if I keep pressing equals. Right, so my answer anyway, 3 decimal places, is 2.153. 3 decimal places, 2.153. Okay, but if I just show you, if I keep pressing equals on here, it's going to get closer and closer to a specific number, or should do at least. Now that specific number will be the solution to the equation. It's still going up here. It seems like it's getting closer, 2.5 something. 2.52 it seems to be sticking at now. 2.53. It's stuck on 2.5 though, definitely. And the more times I press this, the closer and closer it's going to get. So I'll keep pressing this until it doesn't change, and then I'll show you. I'll put this back into the original equation and show that we should get, well, that we do get 0. So 7, it's still changing a little bit at the end. 8, 5, 8, 6, 8, 7, it's still going up slightly. Still change at the end, very slightly, but it's getting closer and closer and closer. It's just that last digit now that's going up and down. 6, 6, 6. Okay, so that's now staying the same. So if I now, that's my answer, I'm going to do this function. So answer cubed minus 3 times answer squared plus 3. Just check I put that in right. Yep, so this should get us very, very close to 0 because this is tiny. This is minus 5, basically divided by 10 times. It's so small because that's so close to the solution. Okay. Moving on anyway, question 17. A factory makes ice cream tubs in 2 sizes, small and large. The tubs are similar in shape. Okay, that's important. So there's got to be scale factors between the lengths, the areas and the volumes. The height of the small tub is 5 centimeters. The volume of the small tub is 150. The volume of the large tub is 500. So 150 to 500. What do I have to times by? Well, if I'm not sure, I can divide the two. So if I do 500 divided by 150, that'll give me the multiplier, if you like, or the scale factor. This is the volume scale factor. 500 divided by 150 gives me 10 over 3. So I'll just leave that as 10 over 3. So 150 times by 10 over 3 gives me 500. Now that is the volume scale factor. So volume scale factor is equal to 10 over 3. Length scale factor is equal to, now volume is cubed units, centimeters cubed. So to get the length scale factor, I need to cube root the volume scale factor. So if I do the cube root of 10 over 3, that'll get me my length scale factor. So if I do shift cube root answer, I'm going to get this thing, okay, 1.493. Okay, I'll just put approximately 1.4938 ... Now work out the height of the large tub. So now the length scale factor I actually need to do 5 times by cube root of 10 over 3. Okay, so 5 times by answer, and that will give me my answer, which is 7.469. So it's to 3 significant figures, so 7.47. Okay, question done. It is only 2 marks, even though it looks really complicated. Okay, question 18. So we've got to complete the square, but it hasn't been expanded yet. So we need to expand it and then complete the square. I'll do this with a grid method, just because I know some people use these. So x minus 8 and x plus 4. This is a multiplication grid. X times x is x squared. X times 4 is 4x. Negative 8 times x is negative 8x. Negative 8 times 4 is negative 32. And then we combine our x terms. So we've got x squared. 4x take away 8 is negative 4x take away 32. Okay, now if I complete the square on this, I'm going to get x minus 2 all squared. Now x squared minus 2x gives me minus 4x, and then this will give me plus 4. So I want to take away the 4, because I don't want to have the plus 4. I want take away 32. So put that take away 32 down here and get rid of 4, because this x minus 2 squared is going to give me a 4. So get rid of that 4, keep the negative 32. So all in all, that's going to give me x take 2 squared take away 36. So our values are 2 for a, because it's take a, and we've got take 2, and plus b, well, b has got to be negative 36. Now what I could do is, just to give me an inkling on whether this is right or wrong, is just substitute in a number to both sides and make sure I get the same thing. So let's try that with 2. So I'm going to do 2 minus 8 times by 2 plus 4, and I get negative 36. Now if I plug 2 into here, I'm going to get 2 minus 2 squared minus 36 is negative 36. So I get the same thing. So I can be relatively confident there that I've got that right. The only thing to be careful of here is they want b. B says, it says plus b. I've got negative 36, so that is in effect plus negative 36. So b is negative 36. Question 19. The sector has a perimeter of 25 centimeters. Perimeter means goes all the way round. If I do this bit here, has got to be 25 take away 9 take away 9, which is 25 take away 18, which is 7. Work out the value of x. Now to get this arc length here, I've got x over 360, because I've got this fraction of the whole circle, times by the circumference, which is pi, times by the diameter, which the diameter, if that's the radius, is 9, the diameter's got to be 18, and that's got to be equal to 7. So I've basically got to rearrange this, and first thing I want to do is I want to times everything by 360, because I don't like this fraction. So let's times everything by 360. Let's get rid of that fraction. Now because they're all multiplication, I don't need to times each thing in here by 360, because this is essentially one thing just split up into 3 parts because they're multiplied. If they were added together, I would have to times each individual thing by 360. So I'm going to get x times by pi times by 18 is equal to 7 times 360, 2520. Then I want to divide by 18 and then divide by pi, and that'll give me my answer. So we'll start by dividing by 18. So divide my answer here by 18, 140. So x times by pi is equal to 140, and then I wanted to divide by pi on both sides. So x is equal to 140 divided by pi. So shift and then standard form button, 44.56. It wants it to one decimal place, so 44.6. Okay, question 19 done. Question 20. M is equal to 1 over P times by S. We've got here already P is 5.37 to 2 decimal places. So lower bound of P is 5.3. This is going to go down the 7 to 6 and then 5. That's the smallest number that when we round it to 2 decimal places we get 5.37. And the upper bound of P is 5.375. Technically it's 5.3749 recurring, but that is so close to 5 that we might as well say 5. Lower bound of S is, that's to 1 decimal place, 2 point, go down 1, 8 and then 5. Upper bound of S is 2.95. Calculate the upper bound for the value of M. We want the biggest value that M could be. Now, we've got 1. If we want this to be the biggest it could possibly be, we want 1 divided by the smallest number. because, for instance, a half is bigger than a quarter, so we want this bottom number to be the smallest it could possibly be, which means we want P and S to be the smallest they could possibly be. And what you could do to make sure is just try the other variations with your bounds, just to make sure that is the smallest one. So upper bound of M is 1 over P. We want smallest number on the bottom, so lower bound of P, 5.365 times by 2.85. Okay, calculator. 1 over 5.365 times by 2.85, and that gives me 0.065. Doesn't say how many decimal places to round it to. 0.0654. We'll go with that. Now, if I just change these to, so for instance, 2.85, if I change that to the upper bound of S, so 2.95, this should be bigger. 0.0631. Oh, sorry, it should be smaller, shouldn't it? Not bigger. Confused myself there, I was saying the wrong thing. This is the upper bounds, this is the biggest it could possibly be, so that is to 3 significant figures. So all of these other ones should be smaller. If I change this to 5.375, again, should be smaller, 0.063. And then the only other variation that I haven't done is 3.75 times by 2.85. Okay, 0.06527, so again, just smaller. And then I'll put it back to what I had before. 0.0654, the 3 significant figures. Okay, question 21. And I think, yeah, we've only got one more question after that. Okay, prove that the area of triangle ABC is equal to a half of AB sine C. Okay, half AB sine C. I know that that is the formula to work out the area of a triangle. What I want to do is I want to think about, well, sine C. Okay. It's half the base. I know a triangle is half the base times the perpendicular height. Area of triangle is half times base times perpendicular height. I know that. So we've got a half. If we say the base is a half times A times, if I do the perpendicular height here, I've then got a right angle triangle, and I can say, well, that's C there, sine C, so sine is opposite over hypotenuse, so opposite over hypotenuse, so that means that sine C has got to be equal to opposite, perpendicular height, so let's call that H, height, over hypotenuse, which is B. Okay, now if I times both sides here by B, I get that the height, the perpendicular height, that is B times by sine C. Now if I then plug that back into here, B times sine C, so we get a half AB sine C. There we go. So that's all to do with actually starting off with what we originally know the area of a triangle to be, a half times the base times perpendicular height, and just working out what that perpendicular height could be using, well, sine, because they kind of tell us that in the question. There's got to be to do with sine. Okay, final question. A solid cuboid has a volume of 40 centimeters cubed. The cuboid has a total surface area of 100 centimeters squared. One edge of the cuboid has length 2 centimeters. Find the length of the diagonal of the cuboid. Okay. Right. Now, and this is essentially going to involve two variables. Okay. That's a nice question to finish off with. So let's say this is 2 here, and that's this side here. We'll call this side bit x, and we'll call the length y. So the volume, so 2xy, 2 times x times by y is 40. And then the surface area is going to be, well, 2x, which is that bit, add 2x, which is the opposite side, add, if we do this side now, xy, add the other xy on the other side, and then I've got 2 times by y, add 2y, add 2y, and that's equal to 100. So we've got 4x add 2xy add 4y is equal to 100. Okay. Now, from there, I know I can replace 2xy. I've basically got two equations here. I've got 1, I've got 2. I can plug 2xy into here and get 4x plus 4y plus 40 is equal to 100. So I'll do that. I'm not sure where that's going to take me though. Substitute 1 into 2. 4x plus 2xy is 40 plus 4y is equal to 100. Take away 40 from both sides and I get 4x plus 4y is equal to 60. And from there I can divide everything by 4. So divide by 4, divide by 4, divide by 4. That's going to get me x plus y is equal to 15. Okay, right, we got somewhere there. Now, from there, basically, to work out the diagonal, if we have a look at the diagram here, the diagonal is going to go from this corner down to this corner. What I need to do is I need to work out, first of all, this diagonal here, so going from there to this corner. Now that is going to be a triangle, and this will probably come into use in a little bit later on. I can use this. I've got a triangle which is going like this, right angle triangle. This is y, that length there I said was 2. So this hypotenuse here is going to be, well, y squared plus 2 squared and then square root it. So that's going to be square root of y squared plus 4, which I don't know at the moment, but that's square root of y squared plus 4. So that is the diagonal that is basically on the bottom of that cuboid. What I then need to do is I've then got diagonal going this way. I've got the height up here. I need to work out this, basically, it's the diagonal that goes from the bottom corner here up to that corner up there. So it's not going along the bottom, it's going up very gradually until you get to there. So I'm going to end up with another triangle which looks like this. This height here is x. This bottom bit here is the square root of y squared plus 4, and we've got to work out that diagonal there. That's the diagonal of the cuboid it means. So I've got to do x squared plus square root of y squared plus 4 squared, and then I'm going to square root the whole thing. Okay, right. So that's going to be the diagonal, whatever it is. So I'm going to get square root of x squared plus y squared plus 4. X squared plus y squared plus 4. Okay. Right, now where do we go from here? We've got that x plus y equals 15. We've got the total surface area of the cuboid is 100. So I'll just check we've done this right. 2 times x, add 2 times x, x times y, add x times y, add 2 times y, add 2 times y. Okay, now I think what the issue is here is basically that I could have solved the equations earlier on, and I've done something which wasn't particularly helpful in the fact that it still left me with both variables in here. Now the whole point of simultaneous equations, or two equations, is that you need to get rid of one of the variables, so then you can work out one of them and work out the other one, which is not what I did. I've got x plus y equals 15, which doesn't really help me at all. So what I'm going to do is I'm now going to leave this because I'll come back to this when I know what x and y are. I'm going to go back up here. I'm going to use equation 1. 2xy is equal to 40, and I'm going to rearrange it. I'm going to divide left and right hand side by, let's go with 2 first of all. So xy is equal to 20, and then that gives me, if I divide left and right hand side by y, x is 20 divided by y, and I'm going to call that equation let's say 3. I'm going to substitute equation 3 into equation 2. Now this will get rid of all of my x values, which is brilliant, because I'll just end up with y's and then I can solve it, which is what I should have done before, but I saw 2xy and kind of got carried away and just substituted it in, and that was never going to get me anywhere. I should have realised that. So 4x, so 4 lots of 20 over y, plus 2 lots of xy, so 2 lots of 20 over y times by y, plus 4y is equal to 100. Okay, now from there I'm going to get 80 over y plus 20 over y times y is going to cancel the y's. I'm going to get plus 40, which is what I had before. Plus 4y is equal to 100. Now I'm going to need some more paper at this point, or I can go on to the next page. What I'm going to do, just so, because I don't have any paper just to hand at the moment. Actually, I can use some paper. I'll just grab some paper very quickly. Okay, so got to this point. What I want to do next is take away the 40 from both sides. So take away 40 from both sides, which is what I did before, but problem is I still had x and y, well, both x and y in there. 80 over y plus 4y is equal to 60. Okay, now this looks a bit weird. What I want to do next is I don't want a fraction there, so I want the times by y everywhere. Times y, times y, times y. Okay, so we get 80 plus 4y squared is equal to 60y. I then want to take away, I'm going to move this up a bit now, 60y from both sides. And then I'm going to get 4y squared minus 60y plus 80 is equal to 0. This is something I should be able to factorise and, well, actually just use quadratic formula on my calculator to solve, but I'm just going to divide by 4 everywhere first of all to make it look a bit nicer. Y squared minus 15y plus 20 equals 0. And if it's taking you too long to work out how to factorise this, just use quadratic formula on your calculator. Now I think it's going to take 4, 5. I'm just going to do this on my calculator, so I'm going to use quadratic formula. So y is equal to minus b, so 15, plus or minus the square root of b squared, so minus 15 squared minus 4 times by a, which is 1, times by c, which is 20, all divided by 2 times by a, which is 2 times 1. So we get y is equal to, and we should plug this into our calculator, 15 plus square root of negative 15 squared minus 4 times a times by c, all divided by 2 times 1, and we get this thing, which is lovely, 13.52 079729, or y is equal to 1.479. 202711. Okay, now I probably want to go through and just check that all works after I've worked out x. So I'm just going to write substitute values into, let's go with, I'll just move this away under here, this one, so equation 3. And then we get x is going to be 20 divided by y. So if I go on my calculator, 20 divided by, and I've written it all down so I can just write it in again, 13.52079729, which gives me 1.479, so on. So basically this same number down here, 1.479202711, or x is equal to, for this y value, well, if I do fraction again, 20 divided by 1.479202711, I'm going to get, yeah, the other y value, 13.52079729. Now what I want to do is I just want to check these, and this is all time dependent on in the exam, that they work in both equations. So because obviously it's simultaneous, it has to work in both. If it works in both, then it's the right answer. It obviously works in 2xy equals 40 because that's the one that I've just used, the rearranged version. Although if you don't feel confident, you can try it on that one as well. I need to make sure it works in this second one. So I'm confident those equations are correct. I just want to make sure all these values are right. Right, so for lots of x, let's go with this top one. So 1.479202.711 plus 2 lots of 1.479202.711 times by 13.520, can't see that, 79729, close bracket, and then plus 4 lots of y, which is 13.52079729, and hopefully this should be equal to 100. It is. Okay, now because that one works, I'm going to assume the other one would work, and actually it's symmetrical anyway, so if I swap these x's and y's, it's the same equation, so it should work. Okay, so I'm confident that's right. Now, once I know this, I can then go back to this thing I had down here, which is x squared plus y squared plus 4, and it's the square root of that. So, square root of x squared plus y squared plus 4 gives me square root of, I'll type all of this, well, I'll write it all down and type it all in, 1.479202.711 squared plus, that's x squared plus y squared, and again, this doesn't matter because x's and y's are the same, so it's not going to matter if I type the other one in, it's going to give me the same answer. So y squared is, well, y is 13.5 2079729 squared plus 4, and it's a square root of that, which gives us the answer. They're going to type all of this in again, which is going to be really annoying, but there we go. 1.479202.711 squared plus 13.5 207.979 squared plus 4. Okay, it gives me 13 point, and what do we want? 3 significant figures, 13.7. Okay, there we go. 13.7 centimeters. Okay, and that's the end of the paper. Okay, as always, you know, if that was useful, if that was helpful, please like, please subscribe. It's helpful to me. It lets me know you like the videos. And yeah, I really appreciate it. And hopefully that this has been useful. Okay, thank you, and I'll see you in the next one.